Hi, everyone. My name is Maria Costantini, and I'm a doctoral candidate in the Zoology Graduate Program, and I've been awarded the Maybelle Roth ARCS Award for Conservation Biology. So to start off, I want you to think about if you have ever gotten to see a Hawaiian honeycreeper in the wild. Unfortunately, if your answer was no, you are definitely not in the minority. But why is that? Why is there such a disconnect between a group of birds that essentially represent the entirety of native land vertebrates in Hawaii and the people that live here? Simply put, most of the birds no longer exist where the people do. While they were once found all the way from the top of the mountains to the sea, today they can only exist at the highest elevations where they are temporarily protected from their biggest threat, avian malaria. These birds symbolize the diversity, beauty, and culture of Hawaii. The bird I study in particular, the akikiki, is one of these honeycreepers. With only about 450 individuals left in the wild, they are predicted to go extinct anywhere between now and 2050. This concern inspired me to investigate the role of the microbiome in Hawaiian honeycreeper health. The microbiome, which is this collection of microbes that live on or within a host, is known to influence behavior, immune function, and just the overall health of hosts. This extremely important aspect of animal health has never been considered in the conservation of Hawaiian honeycreepers, which motivated me to address this connection for my PhD. Because the akikiki is at such a high risk of extinction, birds have already been brought into captivity to initiate an insurance population. However, this shift to captivity disrupts the natural pathways of microbiome formation by changing the diet and removing parental and environmental interactions, which are critical drivers of microbiome formation. With the funding from the ARCS Award, I will use next generation sequencing to determine how exactly captivity affects the akikiki microbiome. Now, this is just the first step to addressing the more important issues functionally. If captivity does change the microbiome, will it decrease the bird's health and ability to fight off diseases? If so, then we are not properly preparing these birds for reintroduction to the wild, which is critical considering their greatest threat, avian malaria. And so after this initial step, I will determine one, how an altered microbiome affects akikiki health by linking microbial community patterns to different health metrics, and two, how to reverse the effects of captivity, such as through inoculations with healthy microbiomes or by altering their captive diet to be more reflective of what they consume in the wild. Not only will this potentially provide knowledge to improve captive breeding efforts for many different species, it will give our native birds a fighting chance against a disease that is driving them to extinction. Thank you so much for listening to me. Have a great day.